Hello, welcome to the next day of notes, which is going to be on rectangles. All right, so let's go ahead and start by defining what a rectangle is. It is a parallelogram, but it's going to have 4 right angles. Sometimes you're also going to see that as 4 congruent angles because it's a quadrilateral. If all 4 angles are congruent and they have to add up to 360, they have to be 90 degrees, which makes them right. So here are the properties of a parallelogram. Opposite sides are both parallel and congruent. Gets that from its above in the hierarchy in the quad tree. It gets it from the parallelogram. Opposite angles are congruent from the parallelogram. Consecutive angles are supplementary. Gets it from the parallelogram. Diagonals bisect each other. Gets it from the parallelogram. And then the new property is that all 4 angles are right angles. So it gets that on its own. That starts at the parallelogram level if you look at the quad tree. So all of these in red, it gets from a parallelogram. But the green is its own new property. All right, let's take a look at this right here and discover another property about triangles. If I know ABCD is a rectangle and I draw in the diagonals, we're going to explain why triangle ADC. So let me highlight that in one color. What is the relationship between this blue triangle and triangle BCD? So I'm going to draw this one in red. All right, well, let's see. These 2 triangles, AD is congruent to BC because opposite sides, because it's a parallelogram, a rectangle is a parallelogram, opposite sides are congruent. And then DC is congruent to DC because of reflexive property. They share that side. Then, because this is a rectangle, I know that in this corner, angle ADC is a right angle, and angle BCD, that's a right angle. So now, if you look, what do we have here? We have side, angle, side for both of these triangles. So if this is the blue one that I highlighted, we have the side, angle, side, and then side, angle, side. And I probably should have switched those colors so it matches my triangles, but that's okay. So what would be true about segments AC, this one, the hypotenuse of the blue triangle, and segment BD, the hypotenuse of this triangle? Thinking back to congruent triangles in that chapter that we did, we learned something called CPCTC, which is corresponding parts of congruent triangles are congruent. So now that I know that the 2 triangles are congruent, I know all of their corresponding parts. So the ones that aren't listed as like sides or angles, all of those are congruent. So I would know this top angle has to equal this top angle, and then what else am I missing? Oh, this bottom angle and this bottom angle, and then finally I would know that AC has to be congruent to BD. Oops, because of CPCTC. Those 2 segments are congruent. So let's see. It tells us here, if a parallelogram is a rectangle, then its diagonals are congruent. Remember, in a parallelogram, that wasn't a parallelogram property, but it is a property of a rectangle. So if ABCD is a rectangle, then the diagonals are going to be congruent. So what can we conclude about triangle DEC, AEB, AED, and BEC? Well, let's see. DEC, I'm going to highlight these again because when it's all overlapping like this, it's kind of hard to tell. So what can we tell about this triangle, DEC and AEB? Okay, AB congruent to DC because opposite sides of a parallelogram are congruent. We know that diagonals they're congruent and they get bisected. So what happens here is that AE is congruent to EC, and then DE is going to be congruent to EB because, again, they get split in half, and because they're congruent to each other, they have to all have just, if I do one tick mark, they're all going to have tick marks. So these are, in fact, isosceles, congruent isosceles triangles. AEB is the top one, and the bottom one, DEC. All right, so now let's take a look at the side-to-side triangles, left and right, this one and this one. The diagonals are still going to be marked as they are. I'm not going to change that, but I'm going to put 3 here and 3 here. Notice that now we have also, by side, 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 we have 2 congruent isosceles triangles, which is really nice. And I like rectangles because if I just give you one little angle, any of these angles in either of these blue triangles or red triangles, you can find every single other triangle. angle I mean. Here's what I mean. Let's say I told you this is 100. If this is 100, this has to be 100 because of vertical angles. Now, in a isosceles triangle, the base angles have to be congruent. So if that angle right here took up 100 degrees, what's left for the other two base angles, this one here and this one here, to share? Well, there's 40 degrees for each of them because there's 80 degrees. 100, take away 100 from 180, you're left with 80. 80 divided by 2 would be 40. Then I could find this angle here because it's a linear pair with 100. So this one's 80. Another thing I could have done, I know this full angle has to be 90 degrees because a rectangle has 4 right angles. So this would have to be 50. And this is 50 because the base angles are congruent. This is 40, this is 40, 50, and 50. All right, so it's just a little extra thing that I like to do. Any one angle that I gave you in a rectangle, when you have the diagonals drawn in, you can find all the angles. And we could practice that in class when I see you in person, if it's confusing to you. All right, we have quadrilateral snow, and we're told that it's a rectangle. If SO is 200, then find NE. So basically, we are told that this entire diagonal here, S to O, is 200. Well, because they get split in half, because it's a parallelogram, if the whole thing was 200, this is 100, this is 100. And because it's a rectangle, I could do the same here. This has to also be 200. That gets split in half, so this is 100, and E is 100, and EW would be 100. So our answer here, length of NE is equal to 100. Again, in a parallelogram, I wouldn't be able to do that. If I have just one diagonal's length, I could split it in half, but I cannot at all. It doesn't tell me anything about the second diagonal. In a rectangle, it does. All right, here again, we're given a quadrilateral, DEFG. It is a rectangle from F to D, and I always, those of you, if you listen to me in class, I don't like when I have to draw this. I hate when it's like it's like a weird way to draw this segment when it's all of DF and there's other segments there. And then EG is equal to, so this diagonal is x plus 5. Find EG and find AF. Okay, well, diagonals in a rectangle are congruent, so I know that 3x minus 7 is equal to x plus 5. This becomes a simple algebra problem to find x. I'm left with 2x minus 7 is equal to 5. Add 7 to both sides, and we get 2x equal to 12. Divide by 2, x is equal to 6. Okay, let's go back and make sure we find what we were being asked to find. We're asked to find EG, so that means the length of EG. Remember, if I have capital letter, and nothing above them, no notation, this means that they just want me to find the length of EG, so this answer should be a number. I just found x is 6. 6 plus 5 is 11. And then AF, which is half of a diagonal, if this diagonal is 11, this diagonal is 11. And AF is going to be exactly half. So it's going to be 11 divided by 2, so 5.5. Or I could leave it as 11 halves. Either one of those is fine because they're both exact answers. I didn't have to round when I wrote 5.5. All right, again, quadrilateral, DEFG is a rectangle. They gave me some measurements here. It says the measure of angle EFD, so this angle up here is 2x minus 3. And then they said DFG, this bottom angle, is x plus 12. Because this is a rectangle, I know that this is a right angle. It has to be. So these two angles, if I add them together, they have to add up to 90 degrees. This would not be true for just a parallelogram. If this was just a parallelogram, I'd either have to be told the entire angle's measure, or I'd say impossible. All right, so now 2x plus x is 3x. Negative 3 plus 12 is a plus 9. This is going to equal 90. Subtract 9 from both sides. We have 3x equals 81. Divide by 3. We get x is equal to 27. All right, so let's go back and see what they wanted us to find. They wanted us to find the measure of angle EFD. EFD is 2 times x, which we just found to be 27, minus 3. So this gives me 54 minus 3 is going to equal 51 degrees. Okay, so that's how you do that one. Sorry that I kind of overlapped here. Let me separate that because it looks kind of messed up if you go back and look at it. Okay, so here we're going to label and show calculations, and we're going to explain our results. We're going to determine if ABCD is a rectangle. So whenever you do these, the first thing you're going to want to do is show that it's a parallelogram. Okay, and how am I going to do that? I'm going to do that by slopes or lengths of sides. After you do that, your second step is going to be then show that it's a rectangle. And the way we're going to do that is by showing one of the rectangle properties. So we're either going to show that there's 4 right angles, and the way I would do that is slopes, because if they're right angles, they're going to be perpendicular, correct? So we're going to have opposite reciprocals for slopes. That's how we're going to determine that there's a 90-degree angle happening in the corner of this. Or what I could do is show that the diagonals are congruent. The way I show congruency is by the distance formula. And that's up here when I wrote lengths. That's also a distance formula. Distance formula being the SpongeBob thing. Okay, so I'm going to do this one actually without graphing it. I like to just draw myself a little picture, a little diagram. I'm going to label it A, B, C, D, and the way I label it, I could start with A wherever I want, but now that I've put A there, I have to go in either clockwise or counterclockwise direction to write my other vertices, right? I can't go A, B on top and then left to right go C, D on the bottom. That would be bad. All right, so A is at -4, 0. B is at 2, 4. C is 4, 1, and D is -2, -3. I'm going to start with slopes because I like to do the slopes of all sides. That's my preferred way to do these. So the slope over here is going to be 4 minus 0, y minus y over 2 minus -4. This gives me 4 over 2 minus -4 is 6. This is 2/3. Then I'm going to do the same thing on the bottom for DC. DC is going to be -3 minus 1. Remember, I could start with whichever y value I want. I could start with -3 from D, or I could start with 1 from C. That's my decision. But once I've committed that I'm going to start with the -3 from D, I have to start with -2 from the same ordered pair. All right, so I get -4 over -6. That does reduce to +2/3. So far, I know that AB is parallel to DC. That is not enough to prove that this is a parallelogram. All I know now is I have one pair of opposite sides that's parallel. So I have to find the slopes of the other 2 opposite sides. So I'm going to do right over here. Slope here is going to be 4 minus 1. If I started with 4, I have to start with 2 minus 4. And I get 3 over -2. Okay, slope on this side. 0 minus -3. Just be careful with your negatives and subtracting negatives. -4 minus -2. This is going to equal 3 over -2. All right, so believe it or not, here, what I've just done is I've not only shown that it's a parallelogram, because I've said, and I could write that, I'm going to write that over here. I will say ABCD is a parallelogram because both pairs of opposite sides are parallel. I'm not going to say both pairs of opposite sides are congruent because I did not show that. I showed that both pairs of opposite sides are parallel. And then I would say it is a rectangle because notice what happened. We haven't talked about this yet. I have this slope is 2/3, this slope is -3/2. Those are opposite reciprocals, which means there's a right angle at B. Now, if there's a right angle at B, there's a right angle over here because opposite angles are congruent in a parallelogram. And I know it's a parallelogram because both pairs of opposite sides are parallel. I would also know these two angles are supplements. Because it's a parallelogram, they are supplements. So if that top one, B is 90 degrees, C has to be 90 degrees, A has to be 90 degrees. So I would say AB, it is a rectangle because there are 4 right angles. And that would be my explanation and my proof of what it is. I've explained the shape it is. Now I want to just do one last thing because we haven't really reviewed distance formula. Let's say I did want to find the lengths of the diagonals. I would do, let me just pick a new color here. Let's do some pink. Okay, to find the length of AC, that's the long SpongeBob formula. All right, remember what I showed you or talked to you about in class. I do distance formula. Hopefully I don't know if you're advanced enough yet. If not, you could plug it in. Let me write it really quick. SpongeBob has 2 eyes, a nose, wrinkles because he's squinting. And in here we put our X's, and in here we put our Y's. Okay, so back to what I was saying. How far apart, because we're seeing the distance, how far apart, how many total steps on a number line, picture in your head how far apart -4 and +4 are. They are 8 units apart, and I would square it. Plus, let's do the same thing for the Y's. 0 to 1, how far apart are those? 1 unit apart, and we'd square it. So here we would get the square root of 64 plus 1. This is going to equal 65. Please make yourself familiar again with the distance formula because it is going to come back with these coordinate proofs. Sometimes you're going to have to go further than we did today. So just showing that there's 4 right angles isn't going to mean it's a rectangle. Spoiler alert, it might be a square. And the way we're going to determine that is we're going to have to use distance property mostly. Okay, let's do the same thing for B to D. All right, let me pick a new color so we have some variation here. Let's maybe do gray. I should have done this in gray. All right, so BD. How many total units apart are 2 and -2 on a number line? They are 4 units apart, and you square it, plus how far apart are -3 and +4? They are 7 units apart, and we would square it. So what we would get here is the square root of 16 plus the square root of 49, which happens to also be square root of 65. But that shouldn't be surprising because we already knew that this was a rectangle, and a rectangle has congruent diagonals. So in this case, if I was to show that this is, I would say it's a rectangle because it's a parallelogram with congruent diagonals. Again, once we get even more specific into other shapes, this won't suffice. You're going to have to go a little bit deeper. But for now, that would be fine. I know that typically these coordinate proofs are the most challenging thing in these sections, so don't worry, we will practice them a lot. You're going to get a lot of practice of all the different shapes on that whole quad tree that we've already started looking at in class, and you're going to get practice of showing how to prove it and then how to write the sentence, because a lot of times it's the sentence description of explaining how you proved what it is that gives kids the most trouble. All right, so that's it here. We're going to do chapter 4, day 4. I'll let you know when that's assigned because it comes up a little bit strangely in our schedule. It's going to come up after we do the review. So just from the New York Times, a little bit here about pigeons, that they can count, but they can also learn abstract rules about numbers. an ability that until now had been demonstrated only in primates. So if you need a tutor, look to see if there's a pigeon available. All right, and then by popular demand, ending my videos with jokes. How do you stop an astronaut's baby from crying? You rock it. All right, everyone. Thank you so much for watching. Enjoy your day. Bye.